In this class, we will understand the problem on two-dimensional cartesian system, or if they give a phi function, that is area stress function, how to plot the stress distribution for that given area stress function. Now let us take a problem like this. It's a plane stress problem wherein the area stress function is given like this. So you can see that this is a function of x and y. Phi is equal to, here he has given 3f by 4h into xy minus xy cube by 3h square plus p by 2y square. Here f, h, p, they are all constants. Only variables are x and y. Now the question is, this function is applied to the region included in, it's a closed region, y is equal to 0, y is equal to h, x is equal to 0, and also on the x side positive. So this is, I will explain this later. These are the what you mean by the boundary of the element. Now he has given the stress function like this. Write down the given stress function. So you can simplify this 3f by 4h into xy, just multiply it, minus f by 4h cube into xy cube, it becomes plus p by 2 y square. Now we know the formula to find the stress component, sigma x sigma y dou xy, by if you know the area stress function. Sigma x is given by dou square by dou y square, so that is dou by dou y of dou phi by dou y. So differentiate this given stress function with respect to y once, then once again differentiate. So please keep it in mind when you are differentiating h, f and p, these three are constants, only x and y are variables. If you do that differentiation 2 times, you will get this. So this is your sigma x. So you can observe here is sigma x is a function of both x and y. Similarly, sigma y is dou square phi by dou x square. That means you have to differentiate that given area stress function with respect to x twice. So if you do that, you will get 0 here. So because first differentiation will give like this. Once again, if you differentiate this with respect to x, it doesn't contain any x term. So therefore, all are treated as constants and derivative will be 0. That means in this problem, sigma y is 0. There is no normal stress in the y direction. At any point, there is no normal stress in the y direction. But sigma x, it is depending on both x and y. Similarly, shear stress component dou x phi, formula is minus dou square phi by dou x dou y. So first I will differentiate with respect to x, then I will differentiate with respect to y. You can do anything. First you can differentiate with respect to y also, then you can differentiate with respect to x. You will get the same answer. That means this can be either dou by dou y or dou phi by dou x, or minus dou by dou x of dou y by dou phi by dou y. That is also okay. So whatever you do, you will get the same answer. And you can observe here is this dou xy contains only y term, y square term. There is no x term here. That means dou xy is independent of x. So it is function of only y. So therefore, it is independent of x. So at all the values of x, it is same. So xy is same. That is the meaning. Now these are the expressions. After getting these expressions for sigma x, sigma y, dou xy, next step is to find the values. Those values at some points. How to take the points is, now he has defined here, this stress function is applied in this region. Y is equal to 0, y is equal to h, x is equal to 0 and x positive, like this. That means, now I am going to draw an element like this. So this is the element now. Two-dimensional element you have to find, because this is only x and y. There is no z term. It's a two-dimensional element. What I do is, I will choose the origin here. If I choose the origin here, so 0, 0 here, this I will take as y-axis, vertical, and the axis, horizontal axis passing through the origin, I will take it as x-axis. Now he has given y can vary from 0 to h. Please note that y can vary from 0 to h. So 0 to h means here y is 0. I will take positive h here, negative h also you can take. So that means from here to here it is h, from here to here it is h. That is in y direction. X direction he has not given any boundaries. So I will take L. L as the dimension of this length of this element in x direction. L is the length. Now if you take like this, if this is the origin, these 4 corner points coordinates you can write now. So this is 0, 0. Now this becomes 0 minus h. This becomes 0 plus h. This becomes n plus h. This becomes n minus h. Of course, this point becomes n comma 0. N comma 0. X is n, y is 0. Now these are the points. Now the question is, you know the expressions for sigma x, sigma y, rho x, y. Let us find out those values at these points. Then we have to plot the distribution, stress distribution. Now the points are like this. X is equal to 0 is there here. If you take x is equal to 0, y is equal to 0, this point, so put x is equal to 0, y is equal to 0 in the sigma x expression which we have got here. So then what happens? You are going to get as p, because x is equal to 0, y is equal to 0, this term becomes 0. Similarly, if you take any value of x, so x, whether x is 0 or x is equal to L, so x is equal to L, of course it is different, but x is equal to 0, whatever value of y is there, this sigma x becomes p only, because the terms become 0. So p, that is constant. Next, at x is equal to L, y is equal to 0 at this point. At this point also, you can see you get only p, because this becomes 0, because y is 0. So that means you just go on putting the values of x and y. At these points, find out the value of sigma x. So at first value we got p, second value also p, third value at x is equal to L, y is equal to plus h. That means this point. At this point, we can always name them also. A, B, C, D we can give. So at the point D, and this you can give it as D. Of course, this is origin O. So at this point C, so it is what happens is x is equal to L, y is equal to h. So if you put that here, so substitute here, you will get p minus this, and this at this value, at this point, x is equal to L, y is equal to minus h, you will get p plus here. So please see that if you put y is equal to minus h, y is equal to minus becomes plus. That means, so here if you observe one thing, so for all the values of x, it is constant, that is it becomes p, sigma x value becomes p here. For all the values of y, when x is equal to 0, the sigma x value becomes p, and then these 3 points I have taken, and these are the corresponding values. Now after getting those values, how to plot? So how to plot that we have to see. So what we have to do here is, of course we have got sigma y is 0 at all the points. So there is no question of sigma y here. Draw y-axis, x-axis and the element. Mark the points there where all we have found out the stress component. Now let us draw the stress diagram. So here at x is equal to 0, this is the plane. Y-axis is the plane, or is the axis where x is 0. At x is 0, you can see that sigma x is p. P is positive there. So positive means you can take it as tensile. Now from here to here, from here to here, x is 0. So you have sigma x value. Sigma x you have to plot in the x direction. It is tensile because positive. Therefore, I have to show like this. So on this x is equal to 0 axis, that is y axis, your sigma x value is p here. Next, come to this side. So come to this side. When you come to, so this first point is taken care now. Now x is equal to L, y is equal to 0 with this point. At this point, sigma x value is p here. So that means this value is p here, from here to here. Next, x is equal to L, y is equal to h means it is p minus. So p minus is slightly less than p. So I will take here. Then at x is equal to L, y is equal to minus, it is p plus. That means it is slightly more than p. Now these two are the values. Now join this by a straight line. Why to join by a straight line is, here this is actually a function of y here. So it is a function of y. It is linear with y. I have written here. It is a straight line. If it is y square term is there, then it is parabola. But y term is there. Therefore, you have to join this by straight line. So once you join, after joining this by straight line, you just write arrows away from the element because it is tensile. So this is how you can plot sigma x diagram. So you have to practice this. So whatever varying value function phi they are given, find out sigma x, sigma y, so x, y, and then after give the values of x and y at the boundary points and get their values and then plot. Similarly, sigma y is equal to 0 here. There is no stress plotting for sigma y. The third one is tau xy, shear stress. Shear stress distribution. So here what happens? Once again, shear stress tau xy, you have got this expression. We have got for tau xy. You can observe that it contains only y square term. There is no x term. That means it is independent of x. So shear stress is independent of x. That is tau xy is same for all values of x. Whether it is x is equal to 0 or x is equal to L, so tau xy value remains same. Now how to find the values now? So let us find out that x is equal to 0, y is equal to 0. If you put both zeros, so this term becomes 0 only, you will get this minus 3f by 4h. Minus 3 by f by 4h is at the origin. So here at the origin. Similarly, if you take x is equal to 0, y is equal to plus or minus h means this value. This point and this point. This is plus h, this is minus h. So if you put both, whether you put plus h and minus h here, this y square term becomes h square. Y square, and then y is equal to h or y is equal to minus h. Y square becomes h square, and if you simplify that, you will get 0. So this becomes plus 3f by 4h, it will get the answer, it becomes 0. That means tau xy is 0 at these 2 points. At these 2 points. That means now how to plot that? So here it is minus 3f by 4h. Okay? And here it is 0, here it is 0. And you can see that it is a function of y square. It is a function of y square. Y square means it is parabolic. You can see that. So tau xy is a function of y square. So it's a parabolic. It's not a straight line. Whereas here it is a straight line. Because y term is there for sigma x. For 4xy, y square term is there. It is parabolic. We have to show like this. Now come to this side. If you come to this side, so the points are L comma 0, L comma h and L comma minus h. So if you substitute those values, you will get the same answer because I have given here this tau xy value is constant or it is same for all values of x. Whether it is x is equal to 0 here or x is equal to L here, so tau xy remains same as it is. So you have to show the shear stress diagram like this. Of course, if you take tau xy, of course here it is negative, so you can show downward negative. Here, upward becomes the value because one side is the shear stress negative like this, other side you have to show like this. So this is the shear stress distribution for the given element. So this type of problem they will ask normally. So based on the boundary values, x and y values, we have to decide the element. So they will give the boundaries. X is equal, x can vary from this to this, y can vary from this to this. Based on that, we have to get in the expressions for sigma x, sigma y, tau xy. We have to substitute the values of x and y in those expressions and get the values of the stresses. Then we have to plot. So it is tension away from the element, compression towards the element. And for shear, so depending on the nature, whether it is positive or negative, you can take left side negative and here you can take right side positive, and the profile is decided based on the expression. If it contains only y term, it is straight line. If it contains y square term, it is parabola. So same thing holds true for sigma y also. In this example, of course, sigma y is 0. There is no stress in the y direction at all. So normal stress is 0 in the y direction for the given stress function. So this is the procedure to find the stress components by knowing the area stress function and how to plot the stresses in a two-dimensional element.